This is Cardboard Online Synth, a free online synthesizer that operates in any Chrome browser. Let's demonstrate how Cardboard can model wave interference using its online additive synthesis tools. Here in the upper left-hand corner, you can see two different oscillators. These are what will generate our sound waves. To replicate what we saw in the previous activity, we are going to set both of them to generate sine waves. Now, I will leave the first oscillator on the -2 octave setting, while moving the other to octave 0. For now, I will mute the second oscillator. I'm also going to mute the noise and LFO sections and bypass the filter. In the bottom right-hand corner of the synth, there is a white line in a gray box. This line represents my wave. Watch what happens when I press the C3 key below. You can see as I hold the key, the line becomes a sine wave. When I press C5, I see a different sine wave with a higher frequency. If I mute the first oscillator and unmute the second, I can repeat the process. You'll notice that the frequency of the sine waves on the second oscillator is higher because we are in a higher octave. Finally, if I unmute both and repeat the process, you will notice that the waves are no longer pure sine waves, but have become a different, more distorted shape. This sound and its corresponding waveform are the result of the wave interference. Now I'm going to move my LFO, or low frequency oscillator, to sine and then unmute it. LFOs vibrate at lower frequencies than humans can hear, but their presence will affect the sound. The visual change is more noticeable on the spectrum below the wave. Without the LFO, the sound decays slowly, but with the LFO, we gain this pulse as the volume cuts in and out. Everything up to this point has been adding sine waves, but now we're going to remove, or filter, parts of the sound. When I remove the filter bypass, listen to the change. Filters remove portions of the sound from reaching output. This is what is called subtractive synthesis, as it is the opposite of additive synthesis.